Welcome to this GSWA webinar. I'm Peter Haines from the Energy Geoscience Group. This webinar will discuss recent findings in the Cobb Embayment of the Canning Basin. The webinar is related to a recently published GSWA report which can be freely downloaded from my online e-book shop. I'll just take a moment to introduce my co-authors. Heidi Allen is a paleontologist who was involved with some of the fieldwork and wrote the paleontology section of the report. Michael Wingate and Yongjin Liu are geochronologists who were involved in detrital zircon dating used in the report. Alex Zan is a geophysicist who organised seismic reprocessing and interpretation of a seismic line crossing the embayment. And Louisa Dent accompanied me on the first field trip, and I'll credit her eagle eyes with first spotting the fossils which would lead to a reinterpretation of the age and significance of the embayment. The Cobb Embayment is a 140 km long by up to 40 km wide appendage extending across the Musgrave region basement on the eastern side of the Canning Basin. It is mostly obscured by Cenozoic sand and dune fields, but is crossed by the Great Central Road, which provides access to the area. Sedimentary rocks in the area of the Cobb Embayment were not suspected until the then Bureau of Mineral Resources, now Geoscience Australia, undertook a regional gravity survey of the greater area in the early 1960s. Here I show the first coloured gravity map, published in 1968, which shows the arcuate Cobb gravity depression, named after Lake Cobb, extending from out under the main Canning Basin at the left, across the Scott 1:250,000 scale map sheet, where the Cobb Embayment is mainly situated, and on over the border into the Northern Territory. At the time, this gravity depression was interpreted as indicating a belt of thick sedimentary rocks through this area, with the eastern end presumably completely concealed beneath superficial cover. I'm now superimposing a modern gravity image with the outlines of the Cobb Embayment and the edge of the main Canning Basin as red lines. You can see that the embayment ends within the gravity depression, and east of that point there are actually outcrops of granite and metamorphic rocks over the gravity feature. The sedimentary rocks of the Cobb Embayment are now known to be too thin to explain the gravity signature, which has been most recently reinterpreted as due to a thick package of fault-repeated Mesoproterozoic Bentley supergroup metasediments and volcanics and Warrakurna superseed granite. Minor outcrops of unmetamorphosed sedimentary rocks within the Scott mapsheet area of the Cobb gravity depression were later found during regional geological mapping by GSWA, highlighted here in red, and in water bores also drilled by GSWA to support the proposal for a major mining operation at the Wingelina nickel deposit. Attempts to date the water bore samples by palynology were unsuccessful, but the outcropping rocks of the new Scott map sheet were given a Permian age simply because of some similarity to Permian glacial rocks within the greater region. The Cobb Embayment was defined as a tectonic element of the Canning Basin by Roger Hocking in 1994, with the assumed Permian age retained. Here are total magnetic intensity and first vertical derivative magnetic images of the area. You can see that the non-magnetic sedimentary fill is not that thick because basement magnetic trends show through, but are somewhat subdued. My involvement with the Cobb Embayment began when I noticed how precisely the southern margin of the embayment coincided with the Woodroffe Thrust and its sprays, suggesting that it could either be older than or contemporaneous with the thrust. At that time, activity on the Woodroffe Thrust was assumed to have stopped after the Peterman orogeny, which happened during the Ediacaran to early Cambrian, and before the initiation of the Canning Basin. Because I was already doing fieldwork in the pre-Canning Amadeus Basin just to the north, I diverted to look at some outcrops in the Cobb Embayment to make comparisons with the Amadeus Basin. The next slide will be a seismic image along the Yilgarn Officer Musgrave, or YOM, seismic line, acquired along the Great Central Road in 2011 by Geoscience Australia and GSWA. Note that the line parallels the thrust for 10 kilometres or so, so imaging of the thrust is not expected to be sharp. Because the YOM line was originally processed with parameters designed to enhance deep crustal features, it was not good at imaging the near surface. For this reason, a segment of the line over the embayment was reprocessed with different parameters to better image the near surface succession. Although the resulting image is not brilliant, it suggests that the fill of the Cobb Embayment thickens towards the thrust to a maximum of around about 800 metres and is possibly overthrust by the hanging wall of the Woodroffe Thrust. A recent thermochronology study of the Musgrave region changes the timing interpretation of the Woodroffe Thrust. While there is evidence of its activity during the Peterman orogeny, exhumation and cooling on the hanging wall of the thrust continued on into the Ordovician, and perhaps even to the Devonian based on one sample. Therefore the thrust was still active during the early history of the Canning Basin, which negates the need for the embayment to have formed prior to the Canning Basin. The next few slides will be outcrop photos from the Cobb Embayment. Near the western end of the embayment, near the join with the main Canning Basin, are some outcrops that are inferred to belong to the uppermost Carboniferous to lower Permian grant group, deposited during the late Paleozoic glaciation. These contain evidence of glacial processes such as diamictite and faceted and striated clasts. At the left is an outcrop of diamictite with isolated pebbles and cobbles, see the blue arrow, in a muddy matrix. The centre image shows a faceted chert clast with chatter marks, again blue arrow, typical of glacial activity, and at right a metre-scale rounded quartzite erratic embedded in ferricrete formed over grant group mudstone. However, such facies are not typical of the outcrops further east in the bulk of the embayment, and the grant group is inferred to unconformably overlie an older succession that is the main component of the embayment. This older component of the embayment is defined as the Cobb Formation in the recently published report. These photos are from the base of the succession at the northern edge of the embayment and show the unconformity with underlying weathered basement granite of the latest Mesoproterozoic Warrakurna supersuite. This cross-bedded pebbly sandstone, with transport directions mainly along the strike of the embayment, is likely of fluvial origin. The outcrops shown here are near the centre of the embayment and include sandstone interbedded with recessive and scree-covered mudstone units. These are inferred to be stratigraphically higher than the previous slide. The mudstones sometimes show halite pseudomorphs, indicated by the red arrows, and also commonly desiccation features, indicative of arid evaporative conditions, possibly on supratidal flats or saline playas. Rare biotubation in the sandstone is suggestive of marine influence favouring supratidal flats. Now we go further west, and possibly stratigraphically higher, to the outcrops that have been assigned as the type area of the Cobb Formation. These sandstones, mudstones and rare carbonate outcrops show more evidence of marine influence. The sandstones appear to be variously cross-bedded channel deposits, possibly tidal channels, sandflat deposits, and locally high-energy beach and barrier bar deposits, as I'll show next. These well-sorted medium-grain sandstone beds have low-angle wedge-shaped foresets and abundant current lineations and current crescents, all indicating beach deposits facing westwards. I'll show some associated trace fossils a bit later. The type area also contains the only body fossils found in the Cobb Formation. These are the fragmentary remains of the dermal armour of a group of primitive jawless fish known as Arundaspids. The collected material is yet to be described in any detail, but is likely to include new species. Arundaspids are restricted to the Ordovician. They were first described from the Amadeus Basin in the 1970s and subsequently found in other Australian basins and elsewhere in Gondwana, particularly South America and Oman. Despite being fragmentary, the material is mostly very well preserved. unlike the Amadeus Basin specimens, which are mostly just moulds. The rocks have also yielded fish microfossils, but normal marine shelly faunas and microfossils are apparently absent, which might be explained if the environment was restricted and stressed, perhaps with fluctuating salinity that may have excluded open marine faunas. Closely associated with the fish fossils are arthropod trace fossils known as Cruziana that were most likely produced by trilobites. Specifically, these specimens are assigned to the Cruziana rugosa group, which is known worldwide from the lower to middle Ordovician. The float specimens shown here are all oriented sole up, that is, they've been flipped over. While trilobites were mostly fully marine, recent published evidence indicates that some, including some inferred to be makers of the Cruziana rugosa group, extended into brackish water in upper estuaries during the middle Ordovician. Taken together, the fish fossils and these specific Cruziana suggest a middle Ordovician age for at least the rocks of the type area of the Cobb Formation, although the full age range of the formation is uncertain. Although fully marine Ordovician rocks are widespread in the subsurface of the main Canning Basin and are a hydrocarbon exploration target, this is only the third known outcropping Ordovician unit in the Canning Basin, the other two localities being 600 to 750 kilometres to the north-northwest of the Cobb Embayment. There are other trace fossils in the type area, including a variety of horizontal and vertical burrows, which I won't show, but here are a few interesting ones from those beach bar type deposits I showed earlier. The one at left is an arthropod walking trace known as Diplecnites. At top right is a particularly interesting marking that could be a fish resting or stranding trace. At lower right, Heidi has superimposed a reconstruction of an arandaspid fish to show how closely it matches the size and shape of a typical 20 centimetre long arandaspid. Sandstone beds around the fossil fish horizon often contain white rounded pellets or nodules from 1 to 10 millimetres in size, and sometimes comprising up to 10% of the rock. These are petrographically identified as colophane, that is cryptocrystalline sedimentary apatite, that is isotropic under cross-polars. XRD analysis confirms the composition as fluorapatite, mixed with detrital and orthogenic minerals. Similar phosphate nodules are known from the Middle Ordovician stairway sandstone of the NT Amadeus Basin, which incidentally also contains the first described arandaspid fish fossils and Cruziana rugosa group arthropod traces. The stairway sandstone phosphate pellets sometimes reach phosphorite grade and were extensively investigated by the Bureau of Mineral Resources in the late 1960s and early 1970s as a potential economic resource, although no mining has taken place. The economic potential, if any, of the Cobb Embayment phosphate pellets is unknown. Two samples of sandstone, a coarse-grained immature feldspathic sandstone from the middle of the area, and a fine-grained biturbated sandstone with associated fish fossils from the type area, underwent detrital zircon dating. The fine-grained rock has a zircon age signature similar to marine Ordovician units across the southern Canning Basin, particularly in the large 500 to 600 MA age peak, but it contains very few zircons that could be explained as being of local derivation. The coarse immature sample does have more zircons likely of local derivation, particularly the subordinate broadly 1180 MA peak that perfectly corresponds to the Mesoproterozoic Pichinjara superseric granites that are widespread in the Musgrave province. But even here we see a more prominent 5 to 600 MA age peak that is apparently not of local derivation. This suggests that the sediments of the Cobb Formation were mainly washed in from the marine realm of the southern Canning Basin, with only minor contribution from the local hinterland, at least based on these two samples. This is well known from modern estuaries, which are shown to be mainly filled with marine sediment rather than river-derived sediment. The lower Ordovician maximum depositional age of the fine-grained sandstone, based on the youngest concordant zircon age, is consistent with the other age constraints. This schematic block diagram illustrates the paleogeographic relationship between the various facies seen in isolated outcrops of the Cobb Formation. I haven't had time to discuss all of these, which include very poorly exposed possible conglomeratic alluvial fan deposits along the Woodroffe Thrust. Open marine Canning Basin lies off to the right, with increasing restriction inland towards the left. The type area lies somewhere around that barrier beach system, separating more marine from a lagoonal setting linked by tidal channels. In both age and setting, the Cobb Formation resembles the recently discovered Barnacadi Formation of the Barnacadi Graben on the margin of the Canning Basin, 750 kilometres to the northwest. The Barnacadi Formation is an excellent reservoir that could also be used for CO2 sequestration or hydrogen and other gas storage, given that it lies at depth beneath a good seal of Grant Group diamictite. If the Cobb Formation extends west into the main Canning Basin, it could have similar reservoir possibilities if it lies beneath a seal. In conclusion, the Cobb Embayment formed on the footwall side of the Woodroffe Thrust that was active during the early history of the Canning Basin. The infill of the embayment is wedge-shaped and up to 800 metres thick along the thrust. The recently defined Cobb Formation dominates the embayment in outcrop and records a variety of facies, mainly deposited under marginal marine conditions. Locally abundant fish and trace fossils suggest a Middle Ordovician age. This is only the third outcropping Ordovician unit in the Canning Basin and the first in the southern Canning Basin. Detrital zircon dating indicates that the bulk of the sediment was washed in from the main Canning Basin, mixed with lesser locally derived material. The Cobb Formation may have affinities with other likely Middle Ordovician marginal marine siliciclastic units like the Barnacadi Formation of the Barnacadi Graben, which suggests that the Cobb Formation may have reservoir possibilities if it extends into the main Canning Basin and lies beneath the seal. Thank you. That concludes the presentation.